I think it'll be very exuberant. So, but what this does,
KST2.
KST of 200 and something, wasn't it?
Yeah, I think so.
Yeah. Or even starch. I mean, we need to get some, we need to get some starch, just normal starch out of the grocery store and run this and see. So, but I think SEA is pretty close to that. I don't know what the KST of SEA is. Linda, you might know?
300 or more.
Ah, 300 or more. Okay, so this is probably the most exciting thing we have. Yeah. So the Hartmann apparatus does this. I have a little chamber here made out of strengthened glass. It's not really actually glass, just some kind of a plastic material. It's very strong enough. I have a source of ignition. When I flip this, you can see the element is going to glow red. See it? And then I have a little container at the bottom here. I'm going to put a little scoop of dust, of various kinds of dust, in that enclosure. Then I have a little aspirator here. So with this aspirator, I'm going to just make it airborne. Okay? So let's think about the Pentagon that we talked about. I have fuel, just the right amount, not too much, because if it's too much, it'll suffocate the flame. Not too little, because if it's little, below MEC, it's not going to explode. I have oxygen, certainly in there. I have a source of ignition. I also have a means of making it airborne. Okay, so this version is there as well. Now, on top here, this tube is open on the top. I have little pieces of paper that I've cut to the right size. So certainly this paper is weaker than the rest of this enclosure. So this paper hopefully will act like a vent. Right? So when it explodes, the flame will come out and this will act like a vent. I have a little knob here that I can control the strength of my ignition source. Okay, now this is just graduated from 0 to 10. If you want to be more scientific about it, you can calculate really, how much strength or temperature we have, but this is just not that accurate. In the real ones that you see in labs, there's actually a pressure indicator or a pressure transducer that takes the signal from the pressure inside to a data acquisition system. It also allows you to exactly control the strength of the electric igniter that you have in there, so you know exactly how many millijoules or joules you're putting in there. Any questions? It was nice knowing you. Thank you for showing up.
Let her rip.
So I'm going to start with the lycopodium because this is a reference material. So this is just a little scoop. Again, if I want to be really scientific about it, I would measure how many grams. Then I would take that and divide that by the volume of the tube. So that will give me grams per cubic meter, assuming I have perfect dispersion. So take a little scoop of this, put it in here. This has to be tight because I need an enclosure. I put the cap on here so that when I press the aspirator, the dust goes in here, otherwise it will come out of this little opening here. Okay, now all I need is this version, right? And I'm going to create that. Okay, so you heard the bang. You heard some flames coming out. It was probably not the most exciting event, but you saw flames coming out, I hope. You see the vent that is broken. This failed. Okay. Now let's use another material. I put a fresh vent.
Is there any charring on the vent?
Charring?
Yeah.
Yeah, you can certainly smell it, I think. I can certainly smell it up here. And if you look in here, you'll see some unburned dust that is just sitting there. This time I'm going to use pancake mix. Now pancake mix is of course mostly flour. There's some other stuff, maybe some powdered eggs or some other things in it. Now let's compare this with the other. Okay, so how did that compare? Maybe a little bit louder?
Yeah. What setting do you have it on?
Right now, it's almost at 8. Now, so you can see that this probably was a little bit stronger of an explosion. You know, the vent is a little bit more damaged. So I put another fresh vent there. Now I'm going to put in the sugar fines.
Take any pyro courses in school?
What kind?
Pyrotechnology?
Pyrotechnology? Okay, so sugar fines. Okay, a little stronger.
Yes.
Certainly smells different up here. Anyway.
Just typical household sugar.
That is confectionery sugar, so it's very fine. And you bring up a good point, because if I take granular sugar out of the little packets, that's probably not going to explode. So particle size makes a difference, right?
Surprised there's not more baking accidents than yeast.
Ah, the first industrial explosions, in fact, happened in bakeries. That's when people started realizing that, hey, this stuff can be really bad. Absolutely. So,
What's the cylinder made of?
the cylinder is made out of something that is strong enough. Obviously.
Somebody's got a
Is
pipe.
that a Lexan?
It's some kind of a Lexan.
Stuff? It's not like a typical glass cylinder, no, it's a little bit beefier than that. Fairly thick wire.
Pyrex was probably running on the Pyrex on explosion. Pyrex, Latin 40 cylinder. Wonder if they would
This has more of a plastic feel to it, so I'm thinking Lexan.
He's got plans.
Okay, so now I'm putting SEA. I mean, this is what we have in our plants. We have had explosions and fires due to this, with some severe injuries. So this is for the nasty stuff. At break time, if you come up here and compare the physical characteristics of the dust, I think you'll see a difference on how they feel. Like one of them, for example, is a lot more, what we call, has a very low apex angle. If I pour it on a table, it'll flatten out. Another one kind of makes a nice tall cone. So that determines how easy each of these dusts would be to become airborne. Okay, so. So that was pretty exuberant. Okay, so now imagine if you have a baghouse filter, large, not just a little scoop of this, but many pounds of this in there. And if it explodes, that could be, I mean, this is just obliterated. Okay? So, any questions, any comments?